Well, hello, everybody. Happy April Fool's Day. It is Wednesday, April 1st. I hope you're having a good day. We're going to learn something new today called the square root function, and we'll be working with this the rest of the week. And then some of you will get a well deserved spring break next week and what of a break from online learning. And then the week after that, we're going to be using the square root function quite a bit. So I want to encourage you that if there's anything you don't understand as I'm going through this, to please message me through Google Classroom or send me an email, or we can come up on Google Meet, because what we're learning today is something that's going to be with you for the rest of your math career. Okay, so what we have is called the square root function. And some of you may have seen this little symbol before written down in math books or other different places. You may have had older brothers and sisters that you've looked at their homework and seen them doing this symbol. And this is what we call the square root function, or sometimes simply just the root. And what the square root function is, it is an inverse operation. So let's start off with defining what are inverse operations. And inverse operations are mathematical operations that are the opposite of other operations, or operations that reverse or undo another math operation. So that's what an inverse operation is. So for example, as we look below at some of our common inverse operations, we have positive numbers. So the opposite of positive numbers are negative numbers, represented by a minus symbol. Okay, the opposite, or the reverse, or the undoing of addition would be subtraction, and vice versa. Okay, if you hope you all know what vice versa means, it just means and the other way. So we have multiplication as well, which is a common operation that we do, and the opposite of multiplication is division. And division is represented by the symbol, by this symbol here. And it's also sometimes represented by the slash mark, especially as we're doing electronic stuff, or even as a fraction. Okay? And then we have exponents. So an exponent is something like x squared, or a number squared. And exponents represent repeated multiplication. So this is where the square root, or the root of a number, comes in, is that it is the opposite, or the inverse operation of an exponent. So it simply is going to undo what an exponent does, or reverse what an exponent does. So it's called the square root. Sometimes you might hear it called the root. And it's represented by this symbol right here. Okay? So the square root, or the root of a number, is going to undo what the exponent does. Okay? It's the reverse of an exponent. So the root, or the square root. So if we look here at a definition, we have the operation here that is read and said, the square root of 25. So that's how you would read or say any of these operations. All right, the symbol for the square root is called a radical. And that's the symbol of the square root, or the root of a number. The number in or underneath the radical is called a radicand. So in this particular example, 25 would be the radicand. Okay? So the underlying question for a square root, or the root of a number, is what number times itself equals the number under the radical, called the radicand. Okay? So that's what we are trying to solve here, is what number times itself equals the number under the radical, called the radicand. So if I start here with this example of the number 9, so the square root of 9, what number do you know multiplied by itself equals 9? The answer is going to be 3. Okay? Because 3 squared means 3 times 3, so the opposite of 3 squared is going to be the square root of 9. Okay? So the same thing here with the square root of 16. What number multiplied by itself equals 16? Well, that's going to be the number 4. 4 times 4 is 16. 4 squared is 16. So the square root symbol is undoing that exponent of 4 squared. So the square root of 100. What number multiplied by itself equals 100? That is the number 10. 10 squared equals 100. So the square root of 100 would undo the operation of 10 squared, or 10 to the second power. Okay? So that is what a square root is. Now, in math, there are some other types of roots which you will see as you get into more advanced mathematics. For 8th grade, the majority of what we do in 8th grade math is going to be the square root, and we might do a few cube roots depending on how much time we have towards the end of the year, but we're mainly going to focus on the square root, okay? So the square root of 4 is going to be what number multiplied by itself equals that number, so that would be 2 times 2. And if we wrote that exponentially, it would be 2 to the second power. Okay? So if we look here at the next example, if you notice over here, I have a 3 above the 8, okay? I have a 3 above right over here, which we call the index, which is right there above the 8. So that means I'm trying to find the cube root of 8, or the number multiplied by itself 3 times, that's going to equal 8. So I already know that 2 times 2 is equal to 4. So times another 2 is going to give me 8. So 2 to the third power is going to be 8, and the cube root of 8 is going to be 2. Okay? If I look here at the fourth root of 16, so that means what number multiplied by itself 4 times is going to equal 16? Well, since I already know that 2 times 2 is 4, times 2 is 8, times another 2 is going to be 16. Okay? So then 2 to the fourth power is going to be 16. All right, so if I come down here to what we call the fifth root, again, you'll see over here my index, or my number right above the 32, is a 5. All right, so that means what number multiplied by itself 5 times is going to equal 32. So 2 times 2 times 2 times 2 times 2. All right, so those 5 2's I would write as 2 to the fifth power. And the fifth root of 32 is going to be just simply the number 2. Okay? And then down here, I've got the 10th root. Now, I personally have not computed anything above a fifth root, but you never know where you're going to end up in math, and so you might end up doing a 10th root if you needed to. So the number I have here as my radicand is 10 billion. So the 10th root of 10 billion, or what number multiplied by itself 10 times is going to equal 10 billion, is going to be the number 10. So I'd have 10 times 10, and no, we're not going to type 10 tens. We'll just put a little ellipse there, and I'll know what that means, that I'm going out 10 times. And then, of course, the exponent form of that number is going to be 10 to the 10th power. Okay? So these are other types of roots that you may see. We may work with cube roots in 8th grade, but 4th roots, 5th roots, and you can really have any root that you want. The 10th root was another example. Okay, and you're just looking for that number multiplied by itself that many times, which equals your radicand. Okay, so for the assignment today, using what you know about multiplication, Find the square roots of the following numbers. Ask yourself what number multiplied by itself equals the number under the radical, which would be the radicand. Okay? So, for example, for the square root of 1, what number times itself is going to equal 1? 1. So you would simply write equals 1. Okay? And then you're going to do the same thing for the next one. So the square root of 4. What number multiplied by itself equals 4? So you should already know that's 2 times 2. Okay? So that's what we're going to do. You're going to use what you know about multiplication to do all of these. You will probably see a pattern develop as you work these out to the end of the page. Please make sure you submit this when you are done. And before we go for the day, our launch is going to be: some people come in your life as blessings, some come in your life as lessons. A quote from Mother Teresa: we learn more about ourselves through others. So have a great day, everybody, and I will see you tomorrow. All right, goodbye.